The problem with these quantities is people need to appreciate that we're talking about different patterns of ones and zeros on sets of wires. Remember, it's the address bus that actually lets us access the amount of RAM. So, for example, if I've got 10 wires in an address bus, we use the mathematical function 2 to the 10th power to get the number 1024. That means if I've got 10 wires, I've got 1024 different combinations of ones and zeros that I can use. We call that amount a K. Some people call it a kilo, but that's rare. Usually we just use the word K. If we have 20 wires, we have 2 to the 20th power, and that equals 1,048,576, or 1 meg. So when you hear somebody say 1 meg, they're really not talking about a million. They're talking about just a hair over a million. 2 to the 30th power, take a look at that number for a minute. 1,073,741,824. That is a gig. Now be careful here. Do you notice that I don't say the word byte? I could have a gig of bananas. I could have a meg of Barbie dolls. It doesn't matter. These are just quantities. So make sure we understand we have Ks, megs, and gigs. We also understand that a K is pretty close to 1,000, a meg is pretty close to a million, and a gig is pretty close to a billion, but 1K does not equal 1,000. It's 24 more than 1,000. 1 meg does not equal 1 million. It's about 48,000 more than a million. And 1 gig certainly does not equal 1 billion. It's about 73 million more. Now we're going to run into a lot of conflicts between gigs and billions and megs and millions and Ks and thousands throughout this series, but this is the first place where it really shows up a lot. In particular, if someone says, I have 16 meg of RAM, what they really have is 16 megabytes of RAM. And a meg's not a million. They actually have a little bit more than 16 million bytes of RAM. So, if we understand these quantities, it makes our life a little bit easier when we actually start to look at the RAM itself.